So, what's today? So, what are you going to read today? Yeah. Today we're going to read about in detail the switching now. I have given you the introduction of switching, but today we'll from today on it will take 1 or 2 days maybe, or 3 days, I don't know, to get it the concept clearly. Okay. So we already have discussed these things, few things in it. Then later on we'll move on that. So we have the switched network. If we have a switched network, because we know we have S switches, right? They are basically of three types, right? What is the first? Circuit switched networks, and then there is a message switched network, right? And then there is a packet switched network. And packet switched network itself is of two types. Either it is a datagram networks, or it is a virtual switched networks. Okay, this one, virtual switched network. This is what we do in our data link layer, right? The circuit switching, what we know, is basically done in the physical layer. Datagram networks is done in the network layer. Okay, we'll be reading about TCPs, IPs later on, and we'll understand how this is being done in the network layer. What else? कहाँ पे? Virtual switch network. We will discuss that, and this thing is done in our data link layer. Right? So switching is very important. What is being happened all the time. And now, अब जल्दी से लिखो है, and ask me if you have something. Some issues do ask. Don't talk on a sideways. If you have something, ask me directly. So I'm saying that circuit switching is done in a physical layer. Packet switching is done. Packet switching two types: datagram networks, virtual circuit networks, and then this is done in the network layer and the data link layer. And message switching is not being implemented in the computer networks. In computer networks, we haven't seen the message switching network. Okay, it was the basic thing. Okay, basically the message switching gives birth to the packet switching. The packet switching is done after the message switching, because the birth of packet switching got out of the message switching, right? So let us take them one on one, and then later on we see the switch structures as well. What is inside the switch? How to build a switch? Because basic concept is how to build a switch. That is our topic, right? But we start going for a concept. What is the circuit switching, message switching, packet switching, and all, right? Then switching hierarchies, and then structure of a switch, and then how circuit switching is being done. And maybe tomorrow or the day after tomorrow we will be doing how the packet switching is being done. Okay, so when we say circuit switching, we know we have already discussed that, so not that much we'll be talking. Circuit switching. In circuit switching, this is what our telephone systems were using from very old time. This is being implemented from very old time, right? Because your telephone networks, they were always circuit switching. They implemented circuit switching. But today we have moved to the digital the telephone has moved from analog to digital, so there is a lot more change. But basically, they were implementing circuit switching means we were connecting the circuit, right? A dedicated circuit. We're making a path. A dedicated path was being made. So there needs an initial setup. Like if you want to call a particular person, you have to basically dial a number. The dialing actually is seeking that path. And if the path is available, if there is no busy inside, if the path is available, right, then what I'm saying is the call is made and the circuit is dedicated. But in between, because you have to talk from here to maybe the Alaska or wherever, or Sydney or London or whatever, you want to talk to that country or that state, that city, to the particular person, a dedicated path, a circuit is being created, right, between many switching offices, right from your SORA exchange. What you say them to exchange, they're basically the switching offices. What you call them as an AND offices in the telephone terminology. We call them as an AND offices. Okay, then there are toll offices, primary offices, section offices, and regional offices. Then they will connect to the international office, and so we'll see that hierarchy. That's called switching hierarchy. We'll see that. But basically, what circuit switching will be, it will be like a switch which has some inputs and some outputs, right? Then there will be a lot more. I'm showing only three. There will be many, right? There could be a lot more. Okay, and you want to connect. Say for example, this switch will take you to a particular city you want to go, and you want to do it from here. You are calling from here. From this person wants to talk to this person, right? On this side. Okay, so a switch is made temporarily. A connection is made on this side. Then maybe this with this. Okay, then maybe this with this and this with this, right? We could have a lot of combinations. We will see where is the path, which path is free and which is not free and all. Okay, and if the path is free, if we could make a path out of there, if the circuit is, we can make a circuit, but this circuit is not dedicated. This is called initial setup time. You have the initial setup time that you are initially setting up your connection. Now your connection is made, right? Now unless you don't hang up the phone, it will stay there. That is why your cost comes in the circuit switching. Your cost comes not out of how much of data you send, rather how much of time, what time you are keeping that circuit alive. Okay, means if you are calling some friend and you are not talking, for example रूशत, आपने फ़ोन तो किया लेकिन आप बात नहीं कर रहे हो, यानी कि आप सेंड कुछ नहीं कर रहे हो, लेकिन पैसे आपको फिर भी चढ़ेंगे क्योंकि इट इज़ द कनेक्शन टाइम, राइट? आपने कितने देर ये जो है इसके बरक्स अगर हम पैकेट स्विचिंग बात करेंगे, जैसे इंटरनेट पैकेज आपके होते हैं, आपके 3 GB फ्री है. अगर आप खाली ब्राउजिंग कर रहे हो तो आपको बहुत टाइम निकलेगा उसको. अगर आप डाउनलोड्स कर रहे हो तो उसमें आपको कम ही टाइम लगेगा, बिकॉज आप जितना डेटा ज़्यादा सेंड करोगे, रिसीव करोगे, अपलोड करोगे, डाउनलोड करोगे, उसके बिना पे आपको चार्जेस चढ़ेंगे. ठीक है, अब खाली एक पेज आपने खुला दिया फॉर द ग्रेटर कश्मीर और आपने खुला दिया, आप सिर्फ पढ़ रहे हो उसको, एंड नाउ इट इज़ डाउनलोड, से फॉर इसमें 10 KB और 20 KB ये पेज था. ठीक है, ये तो हो गया, इतना हो गया इसका. बाद में आप डाउनलोड नहीं कर रहे हो, आप इसको यूज़ तो कर रहे हो, पढ़ रहे हो, कनेक्शन तो आपने बना रखा है, यू आर कनेक्टेड, यू आर ऑनलाइन, लेकिन चार्जेस नहीं चढ़ेंगे. ठीक है, वहाँ पे आपको चार्जेस चढ़ते हैं कितना डेटा आपने पास किया ऑन द फ्लो. ठीक है, लेकिन इसमें ज़्यादा ध्यान है टाइम के ऊपर, आपने कितने देर कनेक्शन को कनेक्ट रखा. ठीक है, so this is how we do in a circuit switching, right? Then later on what we did is what's called message switching. We will come back to circuit switching again, because we have to design how we make this circuit switch. And a question which can come is difference between packet switching and circuit switching. So we will discuss some points on that. Then we have a message switching, right? Message switching is what? Message switching is that we are sending the full message, okay, in hop by hop based. Hop by hop. You are having a message, a full message, that's not broken down, a perfect message, a big message you have, whatever the message you have, that is being sent to the particular spot, like we have exchanges here, okay, that is being sent and they store it there, and then send it again, then send it again to the whatever path we have. For example, listen, this is my exchange, because it is a switching, no? Right? So this is one of the exchanges, another exchange. So you are sending your message to this exchange, or a switching office in a better way we can call. Here we usually call them exchanges, right? But better way, they are called as switching offices. You send it to the switching office. This message is stored in entirety here, and then which line we should pass on is being decided and sent on that communication line. For example, this line. Then it goes to the particular next office, stored there in entirety, okay. Then depending upon where it should go, depending on destination, इसको कहाँ भेजना है, okay, a particular communication line is being selected in a switching office, right? You getting me? So means you are not connecting, you are not having a connected circuit. You have sent a message, like your, for example, email message you have sent it, okay, and now it is being passed to particular this thing. You getting me? Like example of this was, this is like an electromechanical networks we have, the like a telegraph. In telegraph, what do we do in a telegraph? We send a message in the office. That message is written on a paper tape, that is being punched on a paper tape. That message is punched on a paper tape. Then it is sent over some communication line. This is your telegram office. Why do you want to send the telegram? This is the office. Your message is being punched on a paper tape and sent on some communication line. We know you have to send to a particular place, so we know this line goes to that place. For example, it is sent over this to this office. For example, here it is again read and punch it on the paper tape, okay. पेपर टेप में आपने पंच किया, ठीक है. अब उसके बाद डिसाइड करना है किस में आपको भेजना है, किस लाइन में भेजना है. Now then again send over this. So this is store and forward network, we call them as something like store and forward. Store and forward. This was basically an idea. I don't think we implement. I don't remember that we have implemented this or not. This message switching was implemented any time or not. I don't think so. Right? This was an idea which gave birth to the packet switching. Because you have the entire message, you have to send an entire message. That means if you are, you are sending data, right? For example, interactive data. You want to talk, if it is an interactive data, right? So can we do message switching over that? For example, we want to call. For example, if we want to call over a for example, VoIP, voice over internet protocol, isn't it? We send like a Skype and all. If we use message switching, we have to wait for the whole message what you are talking, then send it, then read it somewhere, then send it again in the line, and so on. It will be a huge burden because the message could be very big. First thing is the message could be very big. That means you need to have a very big memory in a router, because these are basically the routers who decide what is this in a technical term, what you call it as a switch. There is also a router and a hub. We will read that. There is a difference between them, but their basic idea is same, because they have to decide which way it should go. Okay. Now, is the router having some intelligence or it is passive like a hub? There's some difference. We'll read a lot of things about it. We will read these like gateways and hubs and routers and switch. What is the difference between them? But I don't want to confuse it here. So what I'm saying is now, so that a huge message has to be stored in this router or a switch, whatever it is. You getting me? It need to be stored there. So that means it need to be a huge memory. So it can't be stored on RAM. It has to be stored in where? In the hard disk. That will be very slow, right? and that can hog this router as well. अब ये router पूरा hog हो गया एक ही message के साथ, and other messages want to be using this router, they can't. Are you getting me? वो तो फंस गए ना. जो बाकी messages हैं which they want to use this router because उनको भी इसी पाथ से गुजरना है. ठीक है, तो ये तो hog हो गया. It is being hogged by this particular message because it's so big. It hogs this router for a minute. That means other guys can't use this now. You getting me? So to fix this problem, to mitigate this problem, because there are two problems in it. One, that what are the two problems here? Let's document it. The problem number one is huge message needs huge disk. Second, router gets hogged. Third, not good for interactive traffic. अगर interactive traffic है, like we are talking to each other, I'm talking to you, you are talking to me, and this is continuous process. So in this sending huge message and all, it will create all sort of problems, right? So to fix this, to get around this problem or to mitigate this problem, what we're gonna do is we break this huge message into some packets. And when I say packet, remember, when I say packet, listen, look at me. When I say packet, it is the job of network layer. Like I said, data link layer, what it does there? Frames. Yes. Last time I told you, that is the frames. The framing is being done in where? And the packet, when we talk of packets, it's being done in the network layer, the packets. Getting me? How we do packets and all, we will see that. So the basic idea is break this message, do same thing, but break this message, okay, into small packets, okay, into very small packets. If the packets are small, number one, you do not need the hard disk, okay, no need to store on them the huge hard disk, right, because they're very small. They can be stored in the RAM of the router. That means they're very fast. Number one. Number second, they do not go, then it's not going to hog your router, right, because they are very small. And what we do is, that's the important thing, is we behave that this single packet, basically this packet, it belongs to this message, right? Say for example, this message here, this to this, here to here is a huge message. We have some 100 or 20 or 50 or whatever packets it is made of. We break them into packets. Okay, this packet belongs to this message, we know it, but we behave as if this packet is independent. This is the idea. Okay, and that is where from the term called datagram networks. The datagram networks is the same thing. The datagram network, when we talk of datagram networks, datagram networks or switch networks, whatever, the basic idea in this is to send this packet, okay, like it is independent. Getting me? Sure. And another important thing Datagram network is, it is the connectionless network. This is very important. We will see this when you go to the transport layer and we see the network layer. There we see the connectionless and connected, like TCP and IP. Connectionless and connected, while we have the acknowledgements and all, we will see that how to do that, how to make a connection. But if we have connectionless, that there is no connection, then how is it possible that this packet goes to the particular destination if we do not have a connection, right? And that too error free. This is our job, being a network student. But our job is, you're sending particular thing, it should go exactly to the particular destination and that without errors. That is why this whole story of protocols and all a networking subject you have, so that you can send your message. For example, you are sending from this place an email to your friend in the America, it should exactly go to his email box, or if you are chatting, for example, it should go exactly to his computer, right, and without errors. This is the beauty of, in fact, if you see the World Wide Web, okay, it is something called World Wide Wild, right? It is a jungle, messy, full of traffic, accidents, all kind of nonsense. But still, you manage to beautifully send your message exactly error-free to the destination what you want, right? This is the beauty of this subject, and that's why being a computer networking student, you have to do that. Okay, we will not allow errors or something like that, right? So this is a Datagram network. It's a connection-less network. We'll discuss them later on how to make it. If it's a connection-less, how is it working? Because this can come the question in the mind. If it's a connection-less, then how is it working? We'll see that later on. So Datagram networks is basically a connection-less network, and it is being implemented by the network layer, where the idea is the basic idea, the essence of this thing. Later on, we'll see details of that. To send this packet, a particular packet, as an individual element, as if this is our message. And to make this packet smaller has got a lot of advantages now over the message, which was impossible to implement. Message switching you can implement, right? You can send the whole message to the router, and that will hog the router. You have to send a movie. How can you send a full movie, then store in a router? It is not possible to store in a router. It needs a hard disk, and then send it again and again. So it will simply hog your traffic and all. There will be all kind of accidents. It's not possible. Simply, it's not possible. And I don't know whether message switching is being implemented somewhere or not. And but I don't think so. It should be implemented. But I don't remember. Maybe, but I don't think it will be implemented anyway. So Datagram networks is what we're gonna deal with. And then I'm saying that we have the packets, the small packets. They can be committed in a RAM of the router, okay. And second thing, they can be sent from a different routes now, okay, because your packets, they're individual. They behave as if they have nothing to do with your previous packets. So you can send them in one way, and another packet in another way, another packet in another way. So that means the job what you do in the network layer is how you make this packet so that it is behaving individually, and then when it goes to destination, we exactly know ये किस message का packet है. So we had to do something. We had to make that packet in such a manner that it will be identified that it is of the following message. It is of that message. This packet belongs to that message, and it is packet number this one. Its counting is this one, because it has to fix, because the pieces of something, right? You have to assemble them later on at the destination. So it is the job of network layer how we do that, right? You getting an idea what we'll be doing in the network layer? Good. Okay, so packets are having a lot of advantages over the circuit switching, but don't believe that circuit switching is not a good thing. Circuit switching has various benefits. I will tell you a few things about circuit switching versus because this time the question may come, that circuit switching versus packet switching and all, right? Let me get a little bit bigger pen. Need a broader one. Okay. So let's write circuit switch versus packet switching, right? In circuit switching, we know we have dedicated circuit, number one. This is its advantage, also its disadvantage. But before that, I will tell you that one more point I would like to tell you is about the leased lines. Don't confuse leased line with the circuit switching. Leased line is also, for example, you have an important office, you have the secretariat and all, you have some prime minister's office, okay, or you have some emergency services. There you have a dedicated path. A circuit is made complete. A circuit. It is not like you have to make a setup. You don't have to call. You don't have to ring. You have to only dial some number so that you can connect with that. You don't have to go for setup time. एक सर्किट बना है, जैसे आपका इंपॉर्टेंट ऑफिस जो कौन है, प्राइम मिनिस्टर ऑफिस है, क्या है, यहाँ पे है, एक लाइन बनती है कंप्लीटली डेडिकेटेड, चाहे वो स्विचिंग ऑफिस बीच में बहुत सारे हैं, इनसे नहीं गुजरती हो, इट इज गोइंग फ्रॉम दीज गाइज एंड दीज गाइज, लेकिन ये एक सर्किट हमेशा बना हुआ है, इसको डायनेमिकली बनाने की जरूरत नहीं है, ये बना हुआ है, लगा हुआ है. द सर्किट इज बिंग डेडिकेटेड, इट्स कॉल्ड लीज्ड लाइन. इसमें आपको कोई कनेक्शन नहीं करना, आपको इस तार के से कनेक्ट करना है, बस हो गया. सिर्फ बेल करने के लिए आपको कुछ नंबर डायल करते हैं ताकि आप इसके साथ कनेक्ट हो जाए और बेल हो जाए, बस समझ आती है. इट इज नॉट स्विचिंग, remember it is not, because we don't do any switching there. Leased line is, it is dedicated circuit, always connected. इसमें switching का कोई पंगा नहीं. You got me? There is no switching in it because you are not doing switching. Switching, connecting from this wire or that wire or this wire or that wire, right? We are not doing anything that. It is being fixed circuit. It is called leased line, and it is not switching. And we have leased lines to the emergency services and all. Or some company who needs, for example, a call center who needs they are working on, they're talking with the clients, they need a dedicated circuit. They can't go for something like dialing and all. If they start dialing and all, then sometimes become busy and their business will be down, so they they will buy some leased lines to that company. That leased line will be always connected. Getting me? You don't have to do switching or connection time, nothing else, it's connected. That's a different story, but we are talking about circuit switching. It's also a point to discuss. And when we say circuit switching, we know we have what? We have to make a dedicated. We have to make, we have dedicated, but to make the dedicated circuit. In the leased line, this is always a dedicated circuit. You getting me or not? Does it make sense? Now, if we have a packet switch, circuit switch. Okay, we have to make a connection. I told you like this, we have to make a connection to the particular guy. Then, for example, this is connecting with this guy because I have to go here and so on. Now here is my guy with a telephone. Okay, imagine this is telephone, if you can, right? A circuit is being made, exactly, a circuit is being made with him. The question is, you are talking and there you are pausing a lot of times. When we talk, we pause. Okay, it doesn't seem we pause, but we have the pause between one word and another word. There is a slight pause. When we talk of the speed of the processors and all, okay, nanotechnology, it's a huge gap. And if you're talking continuously, but maximum times we are thinking. When you talk, we are thinking. So, and and like that, you are talking, and there are a lot of pauses. Sometimes, okay, hold on, hold on. We say hold on, and then just hold on it some 2 minutes, 3 minutes, 5 minutes, sometimes 10 minutes. You are not using the line, but the circuit is made. What does it mean? What do you think about that? You are not talking, but a circuit is made, means that circuit can't be used by some other guy now. ठीक है ना? आप इस्तेमाल तो नहीं कर रहे हो, लेकिन कोई और भी इस्तेमाल नहीं कर सकता, क्योंकि यह आपके नाम हो चुका है. This is the biggest drawback of it. ठीक है? आप हॉग कर रहे हो पूरा इसको, हालांकि आप भेज नहीं रहे हो. मैं आपको होल्ड ऑन कह रहा हूं, मैंने नीचे रखा हुआ है. अगर रूश में तेलची पाते हेलो करा पता करा काफी. Like my phone is always the missed calls, and I start, there's nobody is talking, right? So this thing happens all the time, that you are using the channel, okay, but you are not sending anything. Even if you are using, there are a lot of pauses, because when we talk there is a lot of pauses. Okay, You getting me? So question is how to benefit from that. That is the packet switching. In packet switching we do not have a connection time कि कौन सी पाथ आपको सिलेक्ट करनी है. दैट इज बीइंग डन ऑन द रन टाइम डायनेमिकली कि ये आपका पैकेट है, ये फलानी पाथ से जाना चाहिए, ये इस पाथ से जाना चाहिए. ये हम पहले डिसाइड नहीं करते, एक पाथ बना के नहीं रखते. बाद में हम देखेंगे कॉम्बिनेशन ऑफ सर्किट एंड पैकेट स्विचिंग ऑल्सो, राइट, यानी सी वर्चुअल सर्किट्स एंड ऑल. बट पैकेट स्विचिंग का आइडिया ये है कि वी डू नॉट hog the channel at all. We do not, make a dedicated path. Rather, we choose dynamically कि मुझे कहाँ से भेजना चाहिए. So ये एक बेनिफिट है पैकेट स्विचिंग का, ठीक है, सर्किट स्विचिंग के ऊपर. बात समझ आती है. और जो आपकी बैंडविड्थ है, वो लिमिटेड है इन केस ऑफ सर्किट स्विचिंग. आपने कोई बैंडविड्थ रखनी है, आपने कोई पाथ बनाई है, उसी से आपको मैसेज भेजनी है. बट इन केस ऑफ योर मैसेज स्विचिंग यू कैन हैव अ ह्यूज पैकेट्स. ओके, आप भेजते जाओ, कोई प्रॉब्लम नहीं, भेजते जाओ. गेटिंग मी? सेकेंड थिंग, आपका जो है पैकेट स्विचिंग में अगर इस साइड ट्रैफिक जैम है, जो आपका सर्किट स्विचिंग में हो सकता है कि आपको बिजी लाइन आ गई, लेकिन पैकेट्स में बहुत कम चांसेस हैं कि बिजी लाइन आए. वाई? Because you can send anywhere, from anywhere. The packets are broken down and you can send it from anywhere, right? कहाँ जहाँ से भी रास्ता मिले, जहाँ से भी फ्री मिले आपको path, you can go from that, this way or that way. Then you have to reassemble. Overheads ज़्यादा है, पैकेट बनाना फिर उसको reassemble करना and all. There is a lot of overheads, but you are not hogging the traffic. Okay? बात समझ आती है? Are you getting me? लेकिन दूसरा यहां पे चीज है कि जो आपका डेडिकेटेड सर्किट, जो आपका ये है सर्किट स्विचिंग, यू हैव सेंड समथिंग. इफ यू वांट टू सेंड समथिंग, यू हैव कनेक्शन एक बार बनाया आपने, फिर आपको कोई चिंता करने की जरूरत नहीं कि पाथ है कि नहीं है. इट विल ऑलवेज बी देयर, इट विल ऑलवेज गो, नाउ इट इज कनेक्टेड. बट पैकेट स्विचिंग में आपको हर सूरत में ट्रैफिक का जाम हो सकता है. हर पैकेट पे आपको ये लगाना है कि कहां से मैं भेजूं या नहीं भेजूं. पास में आते हैं. There can be traffic jam on every packet. You getting me or not? And now on that case you have also the accidents, the problem of accidents, because you are not dedicating a circuit. आपको अब रास्ता तो बनाया नहीं है ना, उस रास्ते से कोई और भी आ सकता है, एक्सीडेंट भी हो सकते हैं, यानी कि your data can be garbled. So आपको एरर करेक्शन का भी इसमें बहुत ख्याल रखना पड़ेगा, ठीक है. और नेक्स्ट बात ये है कि like we say road versus railroad. The example given by Tannenbaum. Road versus railroad. In the road, right, it is up to you कि आप कौन सी गाड़ी लोगे. Whether you will use a bicycle or scooter or bike or car or truck or jeep, whatever. स्पीड कितनी रखोगे आप तक है ना, आप ड्राइवर हो खुद ही. It is up to you what speed you will choose. ठीक है जनाब, है ना. अच्छा, आप यानी कि सेंडर एंड रिसीवर के दरमियान एक पैक होता है कि भैया हम ये फ्रेमिंग करेंगे, इस तरह की फ्रेमिंग करेंगे, हम ये वाली स्पीड रखेंगे, हम इस तरह करेंगे. आप किस तरह पैकेटाइज करोगे, फ्रेम्स कैसे बनाओगे, स्पीड क्या रखोगे, इट डिपेंड्स अपॉन यू. इफ यू हैव अ रोड लाइक स्टफ. बट इफ यू हैव अ रेल रोड, इफ यू हैव अ ट्रेन, can you decide what will be the speed of your? You can't. Can you decide that? Can you decide the size? Right? You can't. You getting me? So which is road and which is railroad now? That is the question. Now packet switching or circuit switching? Road is packet. Yes. In fact, it is ulta. The road is the which one? The circuit switching. You have a dedicated circuit. Now between the user and the receiver, it is up to you what kind of framing you will do, what kind of speed you will choose and all. But in case of your packet switching, you need a carrier. You need a carrier who will decide, okay, how much you can send and all. We'll see that. This will get clearer in future, I guess. Okay. This was a difference between circuit switching and packet switching. And one more difference is that in circuit switching you will have a time. Okay, the cost will be charged on time. But in packet switching, the charge will be on the base of the data sent. Maybe sometimes a time, but not really the time, right? You're talking from, for example, on a Skype, you're talking to the guy on the other side of the world. He may be other side of the world, or he may be, here. Where? He may be in your next room, right? He may be in your next room. He may be other side of the world. There's nothing like where he is, the distance. The thing is that how much of data you are sending. You will be charged कि आपने कितना खर्च किया. ठीक है, बात समझ आ रही है ना? जैसे आप डाउनलोड कर रहे हो जैसे पीयर टू पीयर कनेक्शन होते हैं, ठीक है, या बिट टोरेंट से आप डाउनलोड कर रहे हो, चाहे मेरे कंप्यूटर से यहीं पे कर रहे हो आप, या कंप्यूटर बंदे का वो अमेरिका में है, ठीक है, लेकिन डिस्टेंस को मैटर नहीं करेगी. मैटर करेगा तो क्या करेगा कि आपने कितना डेटा यूज़ किया. लेकिन सर्किट स्विचिंग में ये मैटर करेगा. जितना आपकी डिस्टेंस होगी उस पर भी कॉस्ट होगा ना. क्यों? डिस्टेंस में क्यों कॉस्ट होगा? अगर आप इंटरनेशनल कॉल करोगे और आप लोकल कॉल करोगे, क्या पैसे सेम लगेंगे? क्यों लगेंगे ज़्यादा? एग्जैक्टली. हमें सर्किट बनाना है बिल्कुल पूरा कहाँ तक, अदर पार्ट ऑफ द वर्ल्ड तक. सो इट विल बी चार्ज. और कितने टाइम पे आपने लगाया, कितना टाइम आपने कॉल को दिया, अगेन विल बी चार्ज. गेटिंग मी? These things are there. So that is why our VoIP, वॉइस ओवर प्रोटोकॉल, जब बात करते हो स्काइप से, बहुत ही सस्ती पड़ती है आपको, है ना. जिनके भी बंदे, जिनके भी किड्स पढ़ रहे हैं अब्रॉड, दे यूज स्काइप. ओके, you getting me? Everybody is using Skype these days to talk. Only me, I guess. For 1.5 years, I have disconnected that. Skype and Messenger is a wastage of time, and there are a lot of drawbacks on that. You should use Skype and all only if you have some relative which is out there. Otherwise, it has a lot of drawbacks. Shouldn't use. Okay, you getting me what I'm saying? Now, next thing is we have done the concepts of the switching. Now, the next thing is our switch hierarchy. जो हमारे स्विचिंग ऑफिसेस होते हैं, telephone, if you are switching offices, right, we have on the top we have regional offices. What we have? There are around, say for example, we talk of them, there are 10 regional offices, okay, which are on the top, regional offices, which belongs to a particular region. Then below that are section offices. Okay. Then below that are primary offices. And then there are toll offices. And then there are end offices, which are your local offices, which you usually see. Not like we have end office, then it goes to that Hari Parbat exchange है ना मशहूर, that is your toll office. Okay, फिर आपके प्राइमरी ऑफिस होते हैं, फिर सेक्शन ऑफिस होते हैं, फिर रीजनल ऑफिस होते हैं जो पूरे रीजन के ऊपर कवर करेंगे एंड ऑल, राइट? You getting what I'm saying? So there are around 10 offices in the regional section. We have 10 offices. Then in a section offices we have something like 63 or something, right? 203 primary offices, tall offices 1300, and your end offices are 19,000. Just check these two numbers, right? They're same or not. There may be something skipped from my brain. So these are our switch hierarchies, and these are in a tree structure. You know, these on the downside, these are arranged in a tree structure. That means when we say tree, why we have a tree? Because a tree has a particular path. If you want a particular point, you will be given a shortest path. You will be given what? If we have a tree, because you know tree data structure, how beautifully we can go from one point node to another node, right? The data structure what we have read, the algorithms which we have read, basically not the programming part, leave it. The algorithms we have read, they are used everywhere. The tree, it is being used here. The same algorithm, how we do that, how we find the shortest path and to go to the particular, because how will a switch decide if I have to go to the particular switching office which path I will use? He will implement the shortest path algorithm, and the path which is short will be used. Getting me? That's why they are arranged in a tree structure, and these guys on the top, right? The regional officer on the top, like a little bit. I will make a diagram. I'm not good at making diagrams, but let me try. 1 2 3 4 5 6 7 8 9 and 10. These are your 10 regional officers, for example. They are on the top, right? And they are fully connected. Remember, they are fully connected. Everybody is connected with everybody, right? They are fully connected using some 45 trunks. They are fully connected with the 45 trunks, high speed trunks. And then because we need to have a trunks wherein we can do what? Multiplexing. We have read about the multiplexing, because our wire will not take a one thing in it. It will taking the calls of 100 people, maybe 1,000 people, maybe, right? One trunk is taking the calls of huge calls together in a one packet, in a one, using the multiplexing. We have read multiplexing, is it? Okay, and in the bottom we have then the primary offices. What is below the original office? Section office. Okay, like here we go. We can make a formula out of here, right? I said internally I have an idea of saying raspata. From that I remember these things. Okay, so you can say raspio or something. मैंने जल्दी में एक बार किया था रसपटा, मुझे रसपटा ही हो गया दिमाग में इसका, एंड ड्यू टू द रसपटा आई रिमेंबर कि कौन किसके ऊपर है. ठीक है, make formulas like that to remember these things, otherwise you don't remember the order. Okay, then we have the like section offices. These are our section offices, whatever the section office number is, and then on the below of that is something like the primary offices and all. They're connected like trees. Okay, and then all other offices, and end offices is where your end office goes, and then the local loop comes in to your home. That's called local loop. We'll read the telephone structure. We'll read it. We'll give one day for it. And then the local loop means these twisted pairs which come to your home from your end office. This is called local loop. So they are arranged in a tree structure. You can understand why I've told you. You getting what I'm saying? Then the next thing which comes in is the structure of a switch. We are telling a lot of things about switch, but how is a switch made now? How is it inside made? And the first thing which we'll read about is a circuit switch. How is a circuit switch made? Okay, so question will be, how is a circuit switch made? And answer is, come tomorrow, I will tell you. So until then, law on the movement, saying, what was that? This is Lalu Prasad's joke, is updated on the Facebook, and I was I was lying for around 10 minutes on that. Really, this joke zabardast, his joke on Lalu Prasad's appointment letter or something like that. Okay, so it's time to say मासलामा. ये किससे हमने बंद रखा था? इसका कौन सा किरदार? 6.